So of course, the first step is reframing the problem to this wine dataset, because of course we don't have the Google Play facilities. We also wanted to make it quite simple. As for data pre-processing goes, we made something very simple. So for the white part, for the white input of the model, let's call it XY. We grab a description of the wine. We have the description, and we convert it to a one-hot vector, one-hot bag of words. This means that XY is going to be of size V, where V is the size of your vocabulary. Okay, and you will have a 1, 0, 0, 1, 1, 1, 0, and so on, 0, 0, 1. Where you have ones in the words that occur in the description. Okay? So that is done in this part. Count vectorizing is a scikit-learn facility to count the words in a corpus. Okay. And if you threshold it, you have a one-hot bag of words. Okay? So that is the input to the wide network. And the intuition behind this is actually the same as they say in the abstract is, well, maybe if some words occur together, that means that the wine is good. For instance, if in the description it says that the wine is good, that probably means that the reviewer gave high rating, right? So these are the kinds of things that you want to memorize, you don't want to generalize. So that is our wide input. And for our and for the deep inputs, so the deep inputs are calculated straight away. What we have is the same vocabulary, but for the description, we're going to have indices. So, so now this is going to become a vector of indices. Let's say 24, 35, 10, 512, or whatever, and so on. And this is going to be the length of the description, so how many words there are in the description. There is a bit of a tricky part here, which is that you need to know what is your longest description beforehand, and then you pad with zeros. That's fine. Which is why you need a padding token, which for us it's 0, and you need an unknown token in case you have a stop word or something like that. You put an unknown token, and for us that was unknown. So unknown is the length of the vocabulary plus 1. So you have all your words from 1 to V, V included, and then V plus 1 is your unknown, and 0 is padding. So in theory, the deep network should be capable of learning that 0 does not mean anything, so it's all padding, and it should be able to learn that this is unknown, so it is just a placeholder for words that you don't understand. Cool. So what does the model do? The model has the wide input. So this is the wide input. They are all connected to your output unit, which is just a dense output. And the input to your deep part is the sum of all these embedded words. Okay, so you have an embedding layer. You have your index, your description as an input. You have your description. This goes through an embedding layer, which then flattens the description into a single vector, and that vector goes into a MLB, and then that feeds there, and here you got your rating. Okay. That architecture is actually very simple to. You guys can see it. So that's your wide input, so just one-hot encodings. So this is a fixed size, so you always know this. And the description goes into an embedding layer, which converts that index into a dense vector, and then sums all the embeddings for a description, and then goes to a multi-layer perceptron. Okay. Sorry if you didn't see that before. That is actually very quick to implement using the Keras functional API.
What dimension you take for the embedding space?
It's a tunable hyperparameter. I'll get there in a moment. So using the sequential API, it's very easy to define all this. Get this out of the way. If you've used Keras before, this is going to look very intuitive. Otherwise, you define your inputs, then you define your embedding, which transforms your deep input, which are all the indices. You sum them all to get a single vector for the whole description. This is playing a bit with the intuition that the sum of the words is going to have a meaning in itself. Okay, that you can do word arithmetic. And then you put all your then you put it through your layers, through your dense layers with ReLU activation. And for your model output, you want to concatenate the wide input and the MLP, which I call model output just to reuse variables. So you're concatenating just before this last unit. And then you have a dense output. With a single unit, which works as your linear regression. Okay? Make sense? So,
Can I just ask?
yeah.
Your for loop is iterating through n units. It would be n layers.
It should be n layers, yes. Yeah. That must have changed not long ago. Well, anyway. It should iterate through n layers. Cool. Yeah. So it iterates through n layers. Now, I'll fix that before loading it. Cool. So that's it, and we use the mean squared error as a loss because we want to be as close as possible to the rating that they gave. So to answer your question, yes, I like configuration files. So I saved several configurations for the models. We can just pass them down into Keras and then it'll take care of it. The first model that I trained was, they're all 2 layers, so they all have the same number of layers. 256 units per layer, so that's the width of the multi-layer perceptron, 2,000 words in your vocabulary, which means that everything else will be treated as unknown. And, well, everything else, and the embedding size you were asking for. So that is going to control how big you want your embeddings to be. So they did fairly well. So of course, this one I trained for only 1 epoch to try and get a baseline of sorts. So that didn't do very well. As you can see, when the reviewer said 91, this is 70. So quite bad always. Then I decided